Students, this is the help video for the first portion of your study guide for Unit 6. Keep in mind how the study guide is going to be graded. You should work through problems 1 through 70 in pencil. Then you should go back and correct 1 through 70 in red pen. Work through questions, key questions 1 through 10 in detail. Good idea to complete it prior to the due date, because I will happily review it. Review all your in-class lessons. Review your preview notes. Review and memorize the basic contents of your reference booklet. Here are the basic contents of your reference booklet for the past couple weeks. I'm going to be going through the flagged problems. Some of these problems are review. We have two parallel lines. And when you have a parallel line cut through a triangle, what you want to do is what's called match and mirror. Match and mirror a proportion. It's a good idea to do this out loud. So listen to how I trace this. That is the top whole side. And I'm going to put that over the top portion. So the match on the other side is going to be the bottom whole side and what's called the bottom portion. So I'm going to do portion over whole equals portion over whole. And the portion I'm going to start with is the top, so that's going to be my unknown, over the whole side, which is 35, equals the portion 16 over the whole. Careful, that's not 4, that's not 16, that's 16 plus 4, so your whole is going to be 20. From here you cross multiply, so I have 20 times x equals 16 times 35. Now, the key to multiplying is not multiplying. You don't actually need a calculator here. In fact, if you can get in the habit of not using one, we're going to factor here. So I asked myself, I'm going to do the 20 and the 35. What goes into both 20 and 35? And that's 5. 5 goes into 24 times. 5 goes into 35 7 times. And now I'm going to do the 4 and the 16. 4 goes into 16 4 times. So I look at what's left. That's 4 times 7. So my x here is going to equal 4 times 7, which is 28. Now, just to check, 28 over 35. 7 goes in there 4 times, 7 goes in there 5 times. 16 and 20. 4 goes in there 4 times, 4 goes in there 5 times. Notice the ratio, 4 to 5. 4 to 5. That's one way you can check these. Taking a look at problem number 5. We have a 30, 60, 90 and a 45, 45, 90. Let's write those charts out. Okay, so for 30, 60, 90, it goes short leg root 3, short leg times 2. So short leg root 3, short leg times 2. That's our long leg and our hypo. That's for 30, 60, 90. 45, 45, 90. Is 45, 45, 90, leg, 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 root 2. Legs are equal. I'm going to wait a moment for you to copy both those down. With this understanding, we take a look here. This is a 45, 45, 90. And this is a leg right here. So all we need to do to go to here is we want to times by root 2. So I'm going to bring it down here. So we have 8 root 6 times root 2. That ends up being 8 root, I'm going to break down the 6 and the 2, 3 times 2 times 2 again. Where did I get 3 times 2? That's from the 6. Now, we have a date. That's going to come out as a 2. So 8 root 6 times root 2 is actually going to be 16 root 3. So this is now 16 root 3. Now that's the hypo. And remember, when it comes to 30, 60, 90, everything goes back to the short leg. So I'm going to identify my short leg here. And then I draw my function arrow. Short leg to the hypo is times by 2. Short leg to the long leg times by root 3. So I take a look here, and I have something times 2 is 16 root 3. That's what I'm asking myself. What is that something? So we basically divide by 2, and we're going to end up with 8 root 3. This way, we're going to take 8 root 3 and times by root 3. Root 3 times root 3 is 3. 8 times 3, this last one, 24. Notice, I just went ahead and found everything, not just X. Always get in the habit of doing that, then just pick off your answers. Number 10, we take a look at what we have here and what we need. There's 2 ways we could do this. I'm going to use round to the nearest 10th. That's a hint that we're using SOHCAHTOA. So from here, I'm going to label from that is our opposite. This is our adjacent. And this is the hypo. Have, need, do. I have the opposite, and I want the hypo. So I ask myself what goes with OH. And it's so. So I write sine of theta over 1 equals opposite over hypo. From here, you circle plug chug, sine of theta. It's going to end up with sine of 60 degrees equals the opposite, which is 20, over our hypo, which is x. You're going to cross multiply and solve for x yourself. Again, round your answer to the nearest 10th. Taking a look here. . It says write out the coordinates of the given shape, find the new coordinates using the transformation, and the transformation is either going to be translation, reflection, rotation. Those three as a unit are called what's called rigid transformations. That means there's no changing of shape, no shape change, no change by size, versus dilation is a non-rigid transformation. So you have to know how to do all three different transformations: translation, reflection, rotation. So for here, we're going to translate one unit to the right. That means we're going to do +1 to the right is positive, and 2 units down, that's the vertical, and we're going down, so we're doing -2. So the first thing we want to do is get our coordinates. So our coordinates here, P is at 2, 3. And N is at -2, 3. And N is at +2, +2. Z is at 1, -3. And S is at -4, -1. Now, from here, we're going to take the whole shape and we're going to shift it 1 unit right, 2 units down. And the way we do that is we simply take all our horizontal coordinates and we're going to add 1. And we're going to take all our vertical coordinates and we're going to -2. So our new coordinates, -2 + 1 is -1. 2 + 1 is 3. 1 + 1 is 2. -4 + 1 is -3. Next coordinate, 3 - 2 is 1. 2 - 2 is 0. -3 - 2 is -5. -1 - 2 is -3. I'm going to plot all these new coordinates in pink. So we have -1, +1. That's our P prime, 3, 0. That's our N prime, 2, -5. That's our Z prime, -3, -3. That's our S prime. And if you connect these, you're going to notice you have the exact same shape. It has just been shifted. Another way you can test this is take any point and we're just going to bunny hop. That's 1 unit to the right, 2 units down. Lo and behold, it works. That's a translation. To slide, add to the left, add to the right. To reflect over the y-axis, first you want to darken the y-axis so it's easy to see. To flip over the y, you opposite the x. So first we're going to get our coordinates here, and y is sitting at -5, +3. And b is at 0, +2. And b is at -4, -1. To flip over the y, you opposite the x. So all we do is we take all these x coordinates and we simply opposite them. So I have 5, 3, 0, 2, positive 4, negative 1. My new coordinates. And if you've done this correctly, you have the same image that's mirrored across the y-axis. We're going to rotate 90 clockwise about the origin. Rotate 90 clockwise about the origin. Now to rotate 90 clockwise, switch and flip to the right. We switch and flip the sign, and if we're doing clockwise, that's going to be to the right-hand side. Let me show you what I mean. So first off, we're going to take each of these coordinates, and I'm going to do the x-coordinate in blue and the y-coordinate in green. So W is sitting at negative 3, positive 4. So negative 3, positive 4. And I is at 0, positive 3. And no, I is not at 0, I is at 1. And U is at 0 and negative 2. And X, 1, 2, 3, is negative 4, negative 1. Okay, there's our coordinates. Let me put my coordinates here. So I have negative 3, positive 4. This is positive 1, positive 3. This is 0, negative 2, and negative 4, negative 1. Okay, to rotate 90 clockwise, switch and flip to the right. So the first thing I'm going to do not do both those steps at the same time. You'll confuse yourself. All I'm going to do is switch all the orders. That means I'm going to take my y's and bring them forward and switch them that order. So ready? I'll keep it color coded. This is just going to be 4, 3, negative 2, negative 1. Now I bring my negative 3, 1, 0, negative 4. Okay, so now I just switched. I'm going to clockwise. Clockwise means I'm going to the right. So watch, I draw a clockwise arrow, flip the sign. Clockwise arrow, flip the sign. Clockwise arrow, no sign to flip. Clockwise arrow, flip the sign. Now I'm going to graph these new points. So positive 4, positive 3. That is my W prime. Start graphing the other points. Now, it's a little hard to see how this has been rotated. So the easiest way is choose any set of points, the same set of points, and draw a straight line to both of them. That way you can see that you actually did rotate 90 degrees. For example, from the origin, there's the origin, we're going to draw a line through W, a straight line through W. Now I'm going to put it through the origin to W prime. Now look, 1, that does look like 90 degrees. 2, I went clockwise in my direction. So that's how you know you're correct. Do the same for those rest. Okay, let's take a look and see what we have here. Says, write out the coordinate points for the boulder to the lighter shape, then write the rule to describe the transformation using translation, reflection, or rotation. So let's take a look here. First, I'm going to get my coordinates. The coordinates of the bowl, so I'm going to do right there. That's 1, 2, 3, 1, 2, 3, 4. So that's 3 and 4 positive. So that means J is at 5 and 4, and L is at 1, 2, 3, and 2. Now I take a look here. K prime is at -4. It's going to be +4, -3, and L prime or J prime is going to be at +4, -5, and L prime is at +2, -3. Now you ask yourself, what has happened? If you notice, first off, we switched the order. This was 3, 4, and this is 4, 3. So we did switch the order. And then ask yourself, notice we flipped the sign there towards the right. We switched and flipped to the right. So what that means is the rule, what's happened here is that we rotated 90 degrees clockwise. And I can test that going from the origin to the same set of points. So origin to L, origin to L prime. Notice that's going clockwise, and yes, there is a right angle there. So you look at the coordinates, and you want to find exactly what is the rule, either translation, rotation, or reflection, and to what degree. Okay, this says state all possible names for each figure. Use the terminology quadrilateral, parallelogram, rectangle, rhombi, square, trapezoid, isosceles trapezoid, and kites. Now, the best place to get your information for this is this giant quad family tree. So notice the markings on this page, and then come over here. And let's take a look and see what we have here. In 31, notice we have all equal sides. So we know it's one, we know it's a quad. That's easy enough. It's quadrilateral. And opposite sides are equal. So it's at least a parallelogram. And lo and behold, all 4 sides are equal, but real careful there is no right angle, so it's not a square. So you ask yourself, what has 4 equal sides and is not a square? And that's going to be a rhombus. It's not a rectangle, again, because there's no right angles there. So you need to go through and name as many descriptive names for each of these as accurately as you can. Here's another example. Okay, so let's take a look here. And I want to point something out to you. We have here what's called consecutive interior angles. They add up to 180 going this way, and consecutive interior angles add up to 180 this way. So that forces the blues to be parallel. But notice the red and the orange are not parallel. So this, well, one, we know it's a quad. It's not a parallelogram, but it is at least a trapezoid. And is it an isosceles trapezoid? Our base angles are equal? And the answer is no. So it's just a trapezoid, a quad and a trapezoid, because it has one set of parallel lines. Taking a look at 50. Says find the measure of each angle indicated, and we want the measure of angle R. Well, you should see to get R, we need that variable. Do not ask yourself what you should do to figure this out. Just simply sweep all four and ask yourself, what do you know about those four angles? Let me color code them for you. We have the blue angle, we have the green angle, we have the red angle, we have the purple angle. And you should know that all four angles of a quadrilateral add up to 360. Use that information to first solve for x, and then plug it in and find the measure of the requested angle. When it says find the measure of the angle in each parallelogram. So now we know we have a parallelogram. We want to find CDB. CDB. So I start at C, I go to D, I go to B. Problem is, I have a variable there, 5x minus 6. So I have to work with what I know is true here. And I don't ask myself, how do I solve for x? I ask myself, what do I know? And if it's parallelogram, I know opposite sides are parallel. So trace those and draw them out. And if opposite sides are parallel, you always want to watch out for armpits of the Z, which means that 28 can come right there. 28 degrees. So now let's see what you have here. We have a triangle. And we have three angles of a triangle. One of them is 28 degrees. Plus the other, that's going to be 22x minus 4. Plus, right there, that's 5x minus 6. And it's a triangle, so it's going to add up to 180. Now your job is to collect like terms, solve for x, and then find your requested angle, which is right there. But you have to solve for x first. So I like to circle my variables and underline your non-variables, collect like terms, and take it from there. Says find the length of the median in each trapezoid. The median. Median means the middle. So both W is the middle of RQ and V is the middle of ST. That's the median. Which means these are the bases. I'm going to start by writing my equation for the median out. Medium equals the average of the bases, base plus base over 2. Now I'm going to circle plug chug very carefully. Median, circle it, plug it in. Base, 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 base. Notice I'm circling. And do not forget the 2. I'm going to actually circle that 2 and bring it down. It's a very common mistake. Put that over 1. Now you cross multiply and solve. 2 parentheses 3x plus 14 equals 1 times 15 plus x plus 48. You can do your own algebra there. Solve for x, plug it in. Make sure you do a check here in the margin. Whatever you get for the bases, make sure they actually average out to the medians. I want to see your math for the check there. I'm going to be looking for that. Number 58, it says find the measure of the angle indicated in each trapezoid. Now, there's a couple things you need to remember about trapezoids. We have one set of parallel lines, so I'm just trace and stretch those out and do the little arrow feathers. I'd like you to trace and stretch this out. Remember this whole stir stick thing? So I'd like you to squiggle these two. You should recognize those as what's called consecutive interior, also known as same side interior. Those always add up to 180 degrees. So I know angle 7x plus 43, circle it, plug it in. Plus the other angle, 3x plus 27 equals 180. Again, collect like terms. Solve for x, plug it in, make sure your answer adds up to 180. It says trace the sides, count the number of sides. The shape is a regular shape. Find the measure of one interior in each polygon. Now, one interior angle is, remember, it's equal to sum over sides. And the sum of interior angles, sides minus 2 times 180. So to find one interior angle, n minus 2 times 180 over n. Now all we have to do is figure out the number of sides. Count yourself, hatch mark each side. It is regular as you go. So I just double checked, n equals an 11. So I come down here, I'm going to take that 11 and I plug it in right here and right there. And I know 11 does not go in that evenly. It is a decimal. So at this point, I'll allow you to use a calculator once you have done your plug-ins and you've gone as far as you can. So 9 times 180 divided by 11. And round your answer to the nearest tenth. So 147.3. This says, trace the number of sides. The shape is regular. Find the measure of the exterior angle. Now, exterior angle also equals sum over sides, just like the interior. What's different is what defines the sum. So remember, the sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. So to find an exterior angle, that's 360 over n. Now just to remind you, the exterior angle are these angles if you trace and drag out the sides like a pinwheel. In fact, do that for this one. These are the exterior angles. Those always add up to 360. So I'm going to count the number of sides. You're going to finish your math there. It says find the interior angle sum. Interior angle sum. Round your answers to the nearest tenth. So this is the sum of the interior angles. So we write here sum interior angles. The sum of interior angles, sides minus 2 times 180. So all we have to do is figure out the number of sides. So touch and count. In this case, n equals 10. Looks like that right there. Get your hands off the calculator. You do not use a calculator for single-digit multiplication. You do it by hand. 8 times 0 is 0. 8 times 8 is 4. 64. Carry the 6. 8 times 1 is 8. Plus 6 is 14. Always label what you just found. We just found the sum of the interior angles.